All right, 1.16 is talking about the intermediate value theorem. And apparently the word theorem got cut off up here, so I'm very sorry. Intermediate value theorem, commonly called the IVT, and we can use that abbreviation for all things AP. So if you need to write out that you're using the intermediate value theorem, just call it IVT. Everybody knows what you're talking about. So the official theorem states this: if f is continuous, so continuity is important, on the closed interval AB, f of A cannot equal f of B, and k is any real number between f of A and f of B, then there is at least one number in C, or called C in AB, such that f of C equals k. So here's what we're talking about. I kind of labeled my things wrong down here. Let's call this C. And let's call this one K that they're talking about. Okay, so we have a continuous function drawn there in black. Continuous from A to B on that closed interval. We don't know what happens after that, doesn't matter. And we have f of A not equal to f of B, they're different. K is any number, so I chose K over here on the y-axis between f of A and f of B. At some point, there has to be a C value such that f of C is equal to K. All right, so this tells us that as long as we have a Y value between f of A and f of B, we could find an X value that corresponds to that Y value. It is important that you notice this theorem, the IVT, is only an existence theorem. It doesn't actually tell you how to find something. It only guarantees the existence of something. So we would have to use algebraic methods to find that, which is what we'll be focusing on some of that today. So here, use the IVT to show that the polynomial has a 0 in the given interval. Because it's a polynomial, we know that f of x is continuous. And that is an important condition of the IVT, so we're going to make sure we write that down. So f of x is continuous on our interval here because polynomials are always continuous. If you're using the intermediate value theorem, you have to state that. The other thing is our 0 has to be between f of 0 and f of 1. So I'm going to calculate what f of 0 is and what f of 1 is. So if I plug in 0, I get -1, and if I plug in 1, I get 1 plus 2 minus 1, so 2. Okay, and that tells us, if we're looking at a 0 that's a Y value of 0, we know that 0 is between f of 0 and f of 1 because those were -1 and 2. So somewhere this has to cross the x-axis, somewhere between 0 and 1. Okay, so because those things are true, we can just say, therefore, by the intermediate value theorem, f of x has a 0 in the interval 0, 1. Now this particular question didn't ask us to find it, but we totally could if it did ask us that. We would just find f of c, plug in and set it equal to 0, solve for c. But this one did not have us do that. It just wanted us to show. So we show that the conditions are met, continuous, and that there is, that 0 is between f of 0 and f of 1. And then we make our statement down here, much like in the squeeze theorem. Okay, so here's one. Let f of x be this exponential function, e to the x over e to the x minus 2. Show that f of 0 is less than 1, which is less than f of ln 4. Okay, so we're going to try and do some algebra here to show that f of 0 and f of ln 4 are smaller and larger than 1 respectively. So let's evaluate them. F of 0, I'm going to have e to the 0 over e to the 0 minus 2. Sorry, my zeros don't look like zeros. E to the 0 is 1. So that looks like -1. And f of natural log 4 e to the ln 4 over e to the ln 4 minus 2. E to the ln 4 is 4. This is 4 minus 2. So I get 4 over 2, which is 2. Okay, and 1 falls between that. So negative 1 is less than 1, which is less than 2. So we have shown that that thing is true. Done. Now, so that's one of the things we could do if we were trying to use the IVT to show that there is a C value such that f of C equals 1. The other thing is continuity. So let's check so we can answer this question. Can we use the IVT to conclude there's a value of C such that f of C is equal to 1? We're concerned about the continuity on this interval between 0 and natural log of 4. So let's figure out where f is going to be discontinuous. Because it's a rational function like that, we would have a discontinuity when the denominator equals 0. So e to the x minus 2 equals 0. And we solve 2, natural log both sides, so we get x equals natural log of 2. Okay, this is a discontinuity. So is f of x continuous from 0 to natural log of 4? No. So the answer here is no, because f of x is not continuous on the closed interval from 0 to natural log 4. Okay, so we cannot use IVT. Awesome. Okay, let's use the IVT to show that there is a root of the equation and then actually find it. So again, we have to, if we're going to use IVT, we have to say that our polynomial is continuous on our interval, which in this case is 0 to 5. We need to show that f of 0 and f of 5 are not the same. F of 0 is going to be negative 12, and f of 5, I don't really have a calculator here. I don't know what that is. Figure that out. And I do know that whatever that is. We have f of 0 is less than, we're looking for a root. Root means that we're finding some C value that equals 0. Okay, and 0 is between those. F of 5, I want to say, is something like 58. I don't remember exactly, but you have calculators, you can figure that out. Now, there's a value that exists. So by the intermediate value theorem, f of C equals 0 somewhere in 0 to 5. Okay, now we want to find it. So f of C just takes c and replaces x in our function. So we will have c cubed minus 3c squared plus 4c minus 12. And if I want to know when f of c equals 0, I'm going to set it equal to 0. Now this is a super fun one, 4 terms. We're going to solve or factor by grouping to solve this. So I'm going to group those first two, group those second two, take out greatest common factors. So c squared from the first group, and I'm left with c minus 3. 4 from the second group, and I'm left with c minus 3. So then c minus 3 is the common factor now, c squared plus 4. C squared plus 4 has no solutions in the real number system, and remember, calculus is only real. So my c value I'm looking for is going to be when c minus 3 equals 0, and c equals 3. So we would say that f of 3 is equal to our 0, or that the root is 3. There's lots of different ways you can say that. We were looking for this value right there. Okay, super cool, right? Mostly just algebra. that's pretty much everything 1.16 is about. Using that new theorem to conclude that we can find a root, and then sometimes finding the root or whatever value they're asking about. So let me know